Hi, good morning again, everyone. This is Dan Brown. Again, I'm one of the hurricane specialists at the National Hurricane Center. Again, broadcasting to you from my home in South Florida. I'm joined by a distinguished panel that I'll introduce here in just a moment. The webinar this morning will be about an hour long. About half of that time, or maybe a little more than half, will be devoted to presentations that you'll see. And then we should have about 20 minutes or so for your questions and answers. There is a question box. We won't see or hear you this morning, but there is a question box in which you can type in your questions. We'll try to answer some of those during the webinar, but then we'll save some of those also for the end. With that, let me go ahead and introduce some of the hurricanes that have affected the east coast of the U.S. Before I introduce our panel. Again, thank you for joining us this morning. We're excited that you're here. We're going to talk about hurricanes, their hazards, and how we forecast these storms. But you can see that over the course of history, there's been a lot of storms that affected both the east coast of the U.S. and even the far northeast as well. Some of the more recent storms were Bob back in 1991, and then Sandy and Irene over the past decade that have not only brought that significant storm surge, but also heavy rainfall and strong winds. So again, we'll talk about some of these storms and again, talk about how we make those forecasts. So next, let me introduce our panel of experts that is here with me this morning. First, I have Robbie Berg. Robbie's going to take us through the first part of the presentation. He's one of our hurricane specialists, also at the National Hurricane Center. I'm also joined by Rich Henning. Rich is flight meteorologist, flight director for the NOAA Aircraft Operations Center. He's one of those folks that flies right into the heart of the hurricanes, the eye, and he's going to tell you how he does that. And you can also ask him lots of questions at the end. So also have John Cangialosi. You don't see John's picture up on the screen at the moment, but trust me, John is there. John's going to help me moderate the questions and answers. We can only put 6 webcams up at a time, so John is not visible at the moment. I'm also joined by Andrew. Andrew's a forecaster up at the National Weather Service office in Boston. Again, it takes a big partnership when we have hurricanes threatening the coast. Not only the folks at the Hurricane Center putting out those forecasts, but those local offices play a vital role. And Andrew and also David are going to tell you what they do there. And David is a forecaster at the National Weather Service office in Upton, New York, covering the Long Island, New York City, Connecticut area, and he's going to tell you about that a little bit later as well. And I'm also joined by Andy Latto. Andy's another hurricane specialist at the National Hurricane Center. Andy's going to take us through that second half of our presentation. And again, everybody will be hanging around for your questions and answers. So with that, let's get right into the presentation. I'm going to turn it over to Robbie.
Hey, thanks a lot, Dan. So, to get things started this morning, we wanted to quickly touch on what our jobs are as a meteorologist. So, when you hear that term, what is it that you normally think of? What does a meteorologist do? Well, it's actually somebody who studies or forecasts the weather. And you can see on your picture, on your screen there, some pictures of meteorologists in action. Many of these are some of us from the Hurricane Center doing our jobs forecasting hurricanes. But you're also probably well aware of sometimes you have meteorologists on TV that tell us about the weather. Well, there's a bunch of different types of meteorologists. There's a lot of meteorologist jobs that you probably never even see because they're behind the scenes. But the fact of the matter here is that we want you to know that anybody who studies or forecasts the weather is known as a meteorologist. So I and Dan and Andy and Don, we all work at the National Hurricane Center. This is a part of the National Weather Service that's located in Miami, Florida. So you can see there, greetings from Miami. That's kind of a cloudy, rainy day today here in Miami. We're getting ready for a possible subtropical type system to form off our coast in the next day or two. So our hurricane season is already getting started, it seems. But we do forecast for hurricanes and tropical storms over the Atlantic and Eastern Pacific Oceans. So it's a pretty large area for where we forecast storms. You can see there on the screen is some pictures of our building, both from the front and from above. And it's not the prettiest building, but you can see that it's pretty strong. It's made of concrete and steel. And the reason for that is because if we ever get hit by a hurricane in Miami and we still have to do our jobs and go to work, we want to be in a building that's strong and is able to withstand those strong winds from a hurricane. So that's why this building was built the way it is to be really strong, even though it may not be the prettiest building you've ever seen. So at the National Hurricane Center, not only do we forecast hurricanes, but we also forecast wind and wave conditions out on the ocean. So we have a lot of customers who are boaters, maybe they're big ships like cruise ships, and other people who spend time on the ocean, like people that work on oil rigs. They all need to know what the weather's going to be like any day of the year. It doesn't just have to be hurricane season. And we have a group of people at the Hurricane Center that do that type of forecast. They tell people what kind of winds to expect out in the ocean and also how high the waves are going to go, because boaters want to try and avoid those high waves. So even when it's not hurricane season, we still have meteorologists at the Hurricane Center putting out forecasts all year round. Now, I kind of mentioned earlier that the National Hurricane Center is a part of the National Weather Service. Well, what is the National Weather Service? You've probably heard of that before. And where is it located? Well, you look at this map here, I can pretty much tell you that everywhere in the United States is covered by an area that gets forecasts from the National Weather Service. So where everybody here on this webinar lives up in New England, there are several different offices that cover your areas and put out your local forecasts. And that's why we have Andrew and Dave on today to talk about what those offices do. So first off, we're going to go to the Boston Norton office, and Andrew is going to tell us a little bit about what his role is there up in that part of Massachusetts. So Andrew, go ahead and explain to the kids what it is that you do.
Yeah, thank you, Robbie. So I'm Andrew, again, with the forecaster with the Weather Service in Boston, Norton, Massachusetts. So we issue weather forecasts and warnings 24/7, 365. Most of you probably are familiar. Certainly during the winter, obviously we have nor'easters and things like that. So we'll be able to tell you if, you're going to have school or not. But we cover, we forecast for, not just winter, but we also do coastal, we do surf forecasts, we do aviation forecasts. Obviously, so we have a couple of big airports in our area of responsibility, which covers northern Connecticut, all of Rhode Island, and pretty much most of Massachusetts, except for Berkshire County out in the western part of the state. So obviously we have Logan Airport, we have Providence, we have Hartford Bradley International Airport. It's a big airport that we have. So we do all that. Plus we also issue severe weather warnings for severe thunderstorms, which you get every so often. The other sort of neat thing that we do, sort of unique to our office, and there's several of them in the country, that some offices are co-located with the river forecast centers, which they provide forecasts and warnings for rivers, varying in size. It can be small creeks, or it can be larger rivers. So we're actually sort of unique in that sense, where we're sort of co-located with the River Forecast Center that covers the rivers across the northeastern United States. And when it comes to hurricanes, well, obviously we defer to the experts, but we can provide some local input. Obviously, with the Weather Service, when it comes to hurricanes, we're all sort of one weather service, and in terms of when it comes to impacts and things like that, we take the forecast from the National Hurricane Center, and we can sort of speak to sort of local impacts. Yes, but we do obviously coordinate with the Hurricane Center when it comes to hurricanes, tropical storms, and tropical depressions. And sort of just to get us started off, the one thing I wanted to sort of pass on is that the interesting thing about hurricanes up here is that many times they move very quickly. A lot of times the forward speed is actually 20, 30 miles per hour. So a forecaster in our office actually sort of added some more humor to here. It just says the hurricanes you're pretty much in for breakfast and gone by dinner. They're sort of less than a day, or even up to a day as far as impacts goes. So no, that's sort of an overview of the Boston office, and thank you very much.
Yeah, thanks, Andrew. A great overview of what you guys do. Next up, we have Dave Wally, who actually works in the New York Upton office on Long Island. Let's switch to his slide. And once that pops up, Dave, you can take it away and discuss what it is that you guys do in your office in the areas that you cover.
Okay, good morning, everyone. My name is David Wally. I am a one of the lead forecasters here at the New York Forecast Office. And also, I've been the tropical program lead for the office for well over 10 years. And I've had the pleasure of working with some of the guys in the Hurricane Center and through outreach and just being on the phone during actually events like Sandy. Our forecast area is it's a very impactful forecast area, a rather small one. If you look at it, where the bottom left image there, we cover Long Island, New York City metropolitan area, southern Connecticut, and the lower Hudson Valley. Quite a few people in that area. That's why it's very impactful. The middle picture, the top middle is the picture of our office. The top left is a picture of the operations area. Many of our operations areas have changed from time to time, but that's the basic gist of it. There's generally at least three people on operations per shift, and many of us have 4, 5, 6 monitors in front of us looking at computer models, a lot of data. That's our AWIP system there. That's our bloodline there, and that's where we get all of our information. And on the top right there, I just wanted to show you that giant golf ball up in the air. All the Weather Service forecast offices have one of those. That's a Doppler radar that allows us to look inside a storm, see if they're rotating. Besides typically telling you whether it's heavy rainfall or heavy snowfall, we can look into storms, see whether they're rotating. So there's a lot of neat stuff we do. And then the bottom right there, that's an emergency management office of New York City, a rather large office. And when there's a big winter storm or perhaps and most definitely during a tropical system, we will have one of our meteorologist staff there. Andrew did a real good job summing up what the forecast offices do. But our first priority is the protection of life and property, and we do that through timely forecast and warnings. We issue forecasts on marine, on the aviation, winter weather. We issue severe thunderstorm and tornado warnings. But as far as tropical, the biggest thing about tropical, as Andrew had mentioned, is that the Hurricane Center, they're the specialists and they're the experts, and we go with one voice in the Weather Service. And what I mean by that is we follow the forecast of the Hurricane Center specialists. So while the Hurricane Center, they forecast the track and intensity of the low, and they also have storm surge specialists there who help support the field offices, the 122 field offices in the country, and the ones along the coastal areas that are impacted by storm surge. They also assist us in storm surge and forecasting storm surge for our area. So while the Hurricane Center covers the big picture, what we have to do at your local office, the area that we cover, is kind of downscale that and say, what are those impacts? What are the winds? What is the storm surge? What is the rainfall? And what is the potential for tornadoes? What are those going to have for your area? So the Hurricane Center forecasts the big picture, and we kind of take their information and downscale it to the local area. Additionally, some of the big things we do, I showed you the picture in the bottom right there of the New York City Office of Emergency Management. One of the big things is we talk to our state and local partners because they serve you, and we try to basically help them interpret the forecast information so that they can make decisions for you whether or not you need to evacuate and what actions you need to take. So we work with our partners who then make decisions for you to keep you safe. Additionally, we also do a lot of hurricane preparedness information. So it's not just issuing the forecast and the warnings. We also, many times a year, maybe 10 to 20 times a year, we'll go out to community forums and we'll discuss hurricane preparedness information. So there's a lot of information, but most importantly, with the Hurricane Center and the forecast offices, we work hand in hand to protect property and save lives. And that's all for me for now.
Hey, great. Yeah, thanks, Dave and Andrew. So, you guys have important jobs. And I also want to mention that if you guys live in New Hampshire or Maine, we're not forgetting about you. We do have other offices in the Gray, Portland area, as well as up in Caribou, and they do cover your areas. So everybody here in New England is covered by a local National Weather Service office. If you have any questions about radars or balloon launches, be sure to ask those questions in the box there, and we'll get to them when we get to the question and answer part at the end. So now let's dive into actually hurricanes. So what you're seeing here on your screen is an animation of a hurricane. This is Hurricane Harvey that hit the coast of Texas a couple of years ago. It was a strong hurricane, Category 4, when it made landfall. And what do you notice when you look at the satellite picture? You probably notice that big clear spot there in the center. That's called the eye of the hurricane. And the amazing thing about hurricanes, especially these well-developed ones, is that there's a lot of strong winds a lot of storm surge, a lot of heavy rainfall, especially within that eye wall. But right in the center in the eye, it goes pretty calm. So you don't really have much wind. If you were in the eye and you looked up at the sky, you might even see blue skies. So it's kind of a weird thing with hurricanes is all that violent weather is occurring in the circulation, in that where things kind of go around the center. But within the center itself, in that eye, it can be pretty clear and calm. And it's always weird when you talk to people that have been in the eye. And even later, I bet Richard is going to be able to tell you about flying into the eye of a hurricane and what that's like. So again, if you have any questions about that, get ready to ask them when Rich comes on. So you may have heard me say that Hurricane Harvey was a Category 4 hurricane at landfall. Well, did you know that we actually group hurricanes based on how strong the winds are? So that's called the Saffir-Simpson Hurricane Wind Scale. And you can see that scale on your slide there. So we categorize them from 1 to 5 based on how strong the winds are. So if there's 74 to 95 miles per hour, we call it Category 1. All the way up to if the winds are 157 miles per hour or stronger, we call it Category 5. Now this scale was developed by an engineer, Herb Saffir, and a meteorologist, Robert Simpson, and they got together and said, okay, well, we know what these hurricanes hit, they cause damage, so based on the damage that we've seen from these storms, can we rate these hurricanes based on their wind speeds? And so that's what they did. They got together and made this scale. And now this is what we use to describe storms, but only based on their wind speed. It doesn't tell us anything about the rainfall. It doesn't tell us anything about the storm surge or the tornadoes that might occur with the system or with the hurricane. And we're going to get into more of those hazards here in a little bit with Andy. He's going to talk about all of those. But I just want you to realize that this scale only talks about how strong the winds are, nothing else associated with the storm. Now, if we take what's called the major hurricanes, that's categories 3, 4, and 5 on the scale, and we look at where those hurricanes have occurred in history, that's what you see here on your screen. So all of those lines are a different hurricane track, and the yellow parts of the lines are when the hurricane was a category 3, 4, or 5, or a major hurricane. So what do you notice? Well, there's some areas here in the Atlantic where we have a lot of major hurricanes in history. Over the Gulf of Mexico, near Florida and the Bahamas, and then even over the Western Atlantic. Now, you may be looking up in the area where you live and you say, well, I don't see that many yellow lines. And that's true, because lots of times when hurricanes start to get up to the northern part of the Atlantic Ocean, the waters get cold and it's very hard for them to maintain the strong intensity that they had when they were down in the tropical areas. So very few of these hurricanes retain or keep that major hurricane intensity as they get up into New England. But every so often you do get a storm here. Here's a yellow line there, there's another one here that does get close to New England. So even though it might be rare, it's not to say that you never can get storms that strong. And even beyond that, you can still get a hurricane that's category 1 or 2, or even tropical storms that can cause a lot of rainfall and other hazards. So New England is still a vulnerable spot when it comes to hurricanes and tropical storms. We still need to be concerned about that. If we were to zoom in closer to where you guys live, you will notice that we do have tracks of storms that move through your states. So these are all named storms since 1900, where the center of the storm has moved through Connecticut or Rhode Island. And you can see that, in fact, both states have been hit by named storms, whether they're tropical storms or hurricanes. If we continue moving up the coast, you look at Massachusetts and Maine. Again, plenty of storm tracks have moved through those states as well. Massachusetts in particular can be quite vulnerable because you have that little piece of land there with Cape Cod, Martha's Vineyard, and Nantucket that kind of stick out into the Atlantic. And so sometimes storms, even if they miss most of the US coast, they can kind of graze parts of southeastern Massachusetts. So that's kind of a vulnerable spot there. And lastly, if we go up to Maine, you'll notice that we also have had storms that have moved through the state there as well. So again, all the states in New England are vulnerable to tropical storms and hurricanes. Now, we were going to go through this webinar without giving you guys a little bit of a pop quiz. So let's try and do that now. You'll see there's a question on your screen. I'm going to turn it over to Dan here in a second, who's going to open up a poll where you can actually vote on your answer. So here's the question. It's, when is Atlantic hurricane season? Is it A, May through November, B, December through April, C, June through November, or D, all year long? So Dan, if you could open up the poll.
Sure, Robbie. The poll should be open now. I see folks voting, and if you don't mind voting in the poll and not in our question box, hopefully it pops up for everyone. Sometimes we have some folks with issues of it popping up, but hopefully you see it. Looks like a little more than half of you have now voted, so I'll give it another few seconds. And we got a lot of great questions coming in, so thanks for those questions. We're trying to answer a few of those during the webinar, but again, we'll save some of those for the end. So going to give it just a couple more seconds and I'm going to close the poll. Let me go ahead and close the poll and see if I can share those results. So if you can see those, about 2/3 of the folks that voted said June through November, but there's another quarter that said May through November, and I wonder why they're saying that, Robbie.
Yeah, I wonder why. So let's reveal the right answer. The right answer is actually June through November. C, that's the technical answer for when is Atlantic hurricane season. Usually we say it starts June 1st and ends on November 30th. Although, and I think Dan showed that 2 out of 3 of you guys gave that answer, so good job. I will mention though, if you said May through November, we're not going to take off all the points for that because as I mentioned earlier in the talk, we're actually watching a weather system today that might form off the coast of Florida in the next few days. And so we've seen, especially over the past several years, that we often get an Atlantic system, named system form even in the month of May. So even though June 1st is technically the start of the season, it's not unheard of for us to have a named storm form in May as well. So good job on that question. Looks like most of you guys were pretty much in tune with what the right answer would be. Now, as I said, hurricane season runs from June 1st through November 30th. Those are the technical dates. Sometimes we can have some really busy seasons. This is a satellite image from 2018, so this was 2 years ago, when we had a lot of storms in the Atlantic Ocean at the same time. And as forecasters at the Hurricane Center, we have to put out forecasts for all of these storms, whether there's one or if there's 5 or 6 at one time. Sometimes it can get really busy. This particular snapshot here, you can see that here off the Western Atlantic, we had Hurricane Florence at the time, which was making its way toward the Carolinas. We had Tropical Storm Isaac down here in the tropics that was heading toward the Caribbean. We had Hurricane Helene out in the Eastern Atlantic. And in addition to those 3 storms, we had another weather system off the coast of Africa we were watching, and then another one here entering the Gulf of Mexico. So this was a very busy day for us at the Hurricane Center. We were just watching so many different weather systems and putting out their forecasts. Now, if you look at over many, many years to say, when do we see the most hurricanes during the hurricane season? We understand it starts June 1st and ends the end of November, but when do we tend to see the most storms? Well, this campfire looking diagram shows you the answer. You'll notice that the colors kind of go up over time. So we're starting in May and June over here, and then it kind of comes to a peak around September 10th. That's when we say the peak of the hurricane season is. Now, it doesn't mean we always have a storm on September 10th, but it means that historically, that's about the time when we would tend to see most storms. Now, we also like to say that the busiest months on average are August, September, and October. So those 3 months, while we want you to be ready for all of hurricane season, those are the 3 months where it's really important. You really should be watching the tropics and watching to see if anything is heading up toward your area, because that's when we tend to see the strongest storms and the most storms. So August, September, and October, just keep that in mind. Now we have another quiz for you, and we're not actually going to open the poll for this one, but I just want everyone to think about the answers to this question. The question is, what are the primary hurricane hazards? And the answers are either A, high winds, B, storm surge, C, heavy rainfall, D, dangerous surf, or E, all of the above. Just think about that for a second. If you think you know the answer, maybe shout it out. Or if you got your parents in the room and they want you to be quiet, maybe not quite so loud, but think about what you think that answer is. So the actual answer is E, all of the above. So all of those things you see there on your screen, the winds, the surge, the rainfall, and the surf, they're all important in a hurricane. We have to be concerned about all of those. So there's one way I want you to remember these different hazards that we talked about. And I want you to remember this word. It's swift, S-W-I-F-T. Swift as in going really fast. So why is that word important? Because it will help you to remember the different hazards that come along with a hurricane. So for example, the essence SWIFT can stand for storm surge. That's one of the hazards that comes with a storm. And Andy's going to talk a lot more about what storm surge is here coming up shortly. The W is wind. That's what most people think about, right? Hurricanes have a lot of wind. So that one shouldn't be too foreign to you because we understand that hurricanes have a lot of wind. Now the I and the F are combined because they stand for inland flooding. These storms can produce a lot of rainfall, and sometimes that produces lots of flooding as well, not just from storm surge from the ocean, but also the rain can produce flooding as well. And lastly, we have the T, which stands for tornadoes. So we can often see tornadoes in these storms as well. Now there's one other hazard that's not included in this word that we want you to remember, and that is waves and rip currents. And he's going to talk about this one as well, but sometimes you don't even need a storm near the coast to produce waves and rip currents along the beach. So before I turn it over to Andy, we have one more poll quiz question for you guys. Here it is. I'm going to ask the question, and then Dan's going to open up the poll again. It's which hurricane hazard has caused the most deaths in the United States? Is the answer A, wind, B, storm surge, C, flooding, or D, tornadoes? So Dan, if you would please open up the poll.
Thanks, Robbie. This poll should be open. Folks should be able to see that now. A lot of votes coming in. I'll give it a few more seconds. Pretty close vote, but this might be one of our better webinars for folks getting the correct answer. Fingers are crossed here as the votes keep coming in. So I'm going to go ahead and close it now and share those results. And our number one answered by a fraction was storm surge, but number two is flooding. And then number three was tornadoes, followed by wind. So I think at this point we're turning over to Andy, who is going to give you the answer and take us through the second half of our webinar.
All right, thank you, Dan. Yeah, it's a very smart group here. So the correct answer, and the majority actually said this, storm surge is the right answer. I bet you it's because some of you have actually experienced or have a memory of a big storm you had back earlier in the decade, and I'll touch base on that in a minute. Wind, a lot of folks, when they think about storms, they think of the wind because we have these categories, go up to category 5, we talk about 150 mile per hour winds. Winds can cause a lot of damage. The winds you see in the top right hand corner can shred a building. They can send a 2x4 in this left picture right through a tree. So winds are very powerful. It's very prolific and very awe-inspiring videos you can see from hurricanes. So that's what a lot of people think about when it comes to hurricane hazards. But water is what most people don't think about, but really should. The top left-hand corner picture here is showing water rescues from folks that are stranded due to floodwaters from rain. Robbie touched base about a lot of these hazards. The bottom left-hand picture is the water moving inland from the coast due to storm surge, and I'm going to describe that a little bit more here in a minute. Yes, water is what kills. 9 out of 10 people die from water, not the wind. Storm surge is responsible for nearly half the fatalities from tropical cyclones. Rainfall accounts for about a quarter of those, and we say flooding caused by rainfall. Another percentage of these water-related fatalities come from surf, which is when you talk about rip currents or waves or drownings when you're at the beach, or offshore if you have a boat that capsizes. But we still have to remember wind and tornadoes are part of this chart. They are fatal as well and are dangerous. So some of you folks might remember Hurricane Sandy's back in 2012. A lot of you on this webinar are probably very, very young though, but your parents, I know, remember a lot of this. This is a picture of Manhattan on a normal day. Folks are walking on the streets. There's vehicles driving around. When Hurricane Sandy struck, the water rose at least a few feet in downtown in the East Village of Manhattan. Notice this picture, this corner building here, the water's at least a few feet deep, and these are in the streets of the city. So why is storm surge so deadly? So you might be stranded in a building if you chose not to evacuate. Well, let's say you lived in this particular neighborhood before Hurricane Sandy struck. So picture yourself at the beach and you're in a few feet deep of water and a wave hits you. That wave can easily knock you over. Water is very heavy. When these waters move from the ocean inland, when the storm moves on shore, it has very strong force to it, and it can take houses right off their foundations. It can cause homes to crumble. If you do not evacuate, you live in an evacuation zone and storm surge reaches your home, you might not have anywhere to go to escape from it. And that's why it's very dangerous. Robbie talked about flooding rains. So let's say you have a storm that produces very heavy rainfall. Sometimes storms can move slowly. In fact, it doesn't even have to be a hurricane to cause flooding rains. This is an example from Tropical Storm Alin back in 2001 that hit Houston, Texas. Let's say you have very heavy rainfall over a several-hour time period. Normally, when you have rain, the water runs off, goes into the ditches, goes down to the gutters, the lakes, the streams, and it gets away from the area. Well, if there's too much rain, the water has nowhere to go. And so in this particular case, the water flooded the Interstate 10 corridor. And this water wasn't shallow water. This was several feet deep of water. These are semi-trucks trapped in the waters that are in the flooding caused by Tropical Storm Alin. And this actually occurred again in Hurricane Harvey just a few years back in the same area. So what's important to remember about these particular hazards are, ask yourself, do you live in a flood zone for purposes of storm surge? Do you live in a flood zone for purposes of flooding rains? Keep that in mind and try to figure out a plan to evacuate if these threats are going to be approaching your area. Now, Robbie also mentioned tornadoes and waterspouts. Yes, they can occur in hurricanes, and most often they occur in the rain bands as the hurricane approaches the area. And they can produce waterspouts or tornadoes. What's the difference between the two? Well, simply put, waterspouts are over the water, tornadoes are over the land. And yes, waterspouts can become tornadoes and the other way around if the waterspout moves from the water to the land or vice versa. And waves and rip currents. This is a very interesting hazard because the storm could be a few hundred miles offshore. The storm might not even be threatening to hit your area. However, what these storms do, it's like dropping a rock in a swimming pool. It creates these ripples of waves called swell that move to the coast. When these larger waves reach the coast, they can break along the beaches. And when you've been to the beach before, waves break, the water pulls back, and the next wave arrives. Well, this stronger wave action caused by these larger waves can erode the sandbars out there where you would normally stand. In the bottom left-hand corner of the screen, you can see they create these channels. And if you get stuck in one of these channels at the beach, you can get pulled out to sea. That's why it's so dangerous. So when you have these larger waves, it's very hard to escape that pull of the current of the water. And you can see in this right-hand image here, there's ways to escape the rip currents if you get caught in one of these channels to try to escape parallel to the shore. Now, there's ways we try to give folks a heads up when these rip currents are going to be a threat. The weather forecast offices, a couple of these folks here are from those offices, will sometimes issue rip current statements that will highlight the threat, even though the storm might be well offshore. And it might not even be from a hurricane. It could be from other hazards or other cyclones that are out there that aren't tropical related. Also, the beaches often have these flags that will kind of indicate to you what the threat level is for the waters. If you see red or yellow, you probably should be avoiding the waters that particular day. So we talked about all these hazards and whatnot, but how do we know how big these storms are going to be? How do we know where they're going to go, what they're going to do? So what we do is we have all of this information coming in of what's going on now. So we have surface observations that provide data of what's going on currently on the surface across the land areas. We also have ships in the buoys over the water that are transmitting weather observations to us as well over the ocean. We have upper air data from weather balloons, and some of the offices, the weather forecast offices across the country will launch weather balloons normally twice a day, even more frequently when there's a hurricane approaching, to try to sample the atmosphere to determine what conditions might make the storm turn or might make it stronger or weaker. We also, in certain circumstances, will send aircraft into these storms or around these storms to sample them and try to determine what kind of ingredients are going into these storms or how strong they are. We have these satellites in outer space, the bottom left-hand corner picture, as well as earlier from you saw the Hurricane Harvey loop, they take very frequent pictures, snapshots from outer space of these storms, so we can say, okay, well, what does the structure of the storm look like, or where is it going? And we can actually do an intensity estimate just based on satellite alone. If the storm's close to the coast, we have Doppler weather radars that can send signals into the storm to give us a picture of what the structure of the storm looks like. And we can even try to pick up on tornadoes that are happening in the storm as it moves inland. A lot of this data all goes into these very sophisticated computer models that will try to simulate where the storm will go, how big it will grow, and how strong it will be. Now, these computer models aren't perfect, and they try to make a simulation based on the data they have. However, there's always some sort of variation amongst these models. There could be a very little variation. We can have a higher confidence forecast, or there could be a big mess you see in a spaghetti plot where the tracks goes everywhere, and that's a low confidence forecast. It's our job to try to determine what these steering mechanisms are, what are these ingredients going into making these storms stronger, whether it's warmer waters, drier air, or wind shear. We try to determine which ingredients they're picking up on most accurately and determine which scenario is most likely to occur. And yes, we fly airplanes in the hurricanes. I'm going to actually hand this off to Richard for a minute so he can discuss some of his role in tracking these storms.
Well, good morning, everyone. Again, my name is Richard Henning, and I'm a meteorologist. I have a special job in that I'm a lucky guy. I get to fly into hurricanes, and my position on the airplane is called the flight director, because essentially what I'm doing is I'm directing the rest of the crew into the center of the hurricane. And we have a very large team of people on board our airplanes that I work with. But I'm the one that's in charge of making sure that the data gets collected and then it is sent via satellite to the National Hurricane Center, and even more importantly, into the computer models that we've talked about that help forecast the track of the storm. We have two different types of planes with NOAA that fly the hurricane mission. If you look at the plane in the center, in the upper part of the screen, you see a turboprop blue and white aircraft. That's our P3. This flies a very similar mission to what the Air Force folks that you see in the lower left corner fly. That's also a turboprop airplane that flies right through the teeth of the hurricane, right through the eye wall, at usually somewhere between 5,000 and 10,000 feet above the water. And we measure the strongest winds that we can find, and then we get ourselves into the eye. And in the eye, you see there on the right side, the eye of a major hurricane. We're talking the most intense hurricanes, Category 4, Category 5 hurricanes, always tend to be the most beautiful inside the eye. The eye clears out. And there's different scientific reasons why that is, but essentially the air is sinking in the eye, and it dries out all the precipitation, it dries out all the cloudiness, and you end up with this beautiful, what we call stadium effect, where it actually looks like you're inside a football stadium with the stands around you, 360 degrees surrounding the airplane. In addition to plowing right through the center of the storm with our C-130 and our P3 aircraft, we have a high altitude jet that you see in the upper left. We nickname our planes after Muppet characters, and that one is nicknamed Gonzo. That airplane flies way up at between 40 and 45,000 feet. So we're talking about 9 miles up in the sky across the top of the hurricane, and even more importantly, in the environment surrounding the hurricane, so that we can send the data into the computer models that determines the track of the storm. That environment around the hurricane is very critical in steering the storm. Just if you can imagine like a block of wood floating in a stream, we're determining the characteristics of the stream around that block of wood with that jet aircraft. It's a Gulfstream 4 high altitude reconnaissance plane. A lot of you are probably wondering how rough it is. Some hurricanes can be very, very rough when you fly through, some not so much, but we can talk about that later on when we get into the question and answer portion. So again, we're one piece of the puzzle in terms of providing data to the National Hurricane Center forecasters. So I'll go ahead and turn it back to them, and we'll wrap up our discussions. And again, we'll have plenty of time at the end for questions and answers.
All right, thank you, Richard. So when a hurricane's approaching the United States, you'll see folks get on the television. We might be on the national television, or maybe streamed into your local television stations, or maybe folks are actually speaking at your local television stations to you. What we're trying to convey is to folks what the hazards are, what the impacts are. So rather than just looking at what, let's say, the wind speed might be, we might be trying to highlight, oh, there's storm surge is a big threat, or heavy rainfall is a big threat. You're actually getting a glimpse inside the hurricane specialist unit in these pictures, especially the bottom right-hand corner. That's what it looks like in the operations area. So behind these folks on television interviews, we might be back there making a forecast, answering radio interview phone calls, newspaper interview phone calls, and posting things on social media. I'm going to show you the links to all that stuff here in a second. We have Hurricane Awareness Week, actually, that I believe it was occurring just last week, or is it this week? It's a lot going on right now with hurricane preparedness. So actually ongoing, you can get this information. The link's here at the bottom of the page, and also is going to be available here on the next screen. So we want to jump ahead to answer questions for you folks. There's been a lot of good questions, and I'm going to hand it off to Dan and John to try to pass those along to us.
All right, thank you, Andy. Thank you, everybody, for the participation. And let's get on to some of the questions. There have been really great questions you all have been asking, and some that we haven't received on any other webinars. So I am gonna, let's see, I'm gonna make the first question. I thought this one was interesting. Dave, I'm going to send the first question to you. And Andrew, you might also chip in here, because it actually is the border. It's Connecticut. We've had a lot of viewers from Connecticut. And I thought this was an interesting question from Braden. He says, why is Connecticut handled by 3 different offices in the National Weather Service? And can this ever change?
I think the primary reason from what I understand is a lot of it's due to radar coverage. I mean, I think that the offices, the 122 offices across the country, pretty much all have a Doppler radar, and based on the coverage of that area and the area responsibility, I believe a lot of it's based on the radar coverage and severe weather forecasting. And also the radars are also strategically placed for along the coast, also for hurricane tracking as well. So I think a lot comes into that, the hurricane tracking, also severe weather monitoring, and a lot of other things, population you serve. We have heard before many times that, even from state and local officials, that it is at times it can be a bit challenging having 3 offices cover 1 state. So whether that changes in the future, I'm not sure, but there are some reasons for it. I'm not sure if Andrew has anything to share.
Yeah, no, I think it all comes down to radar coverage, like Dave, as you mentioned. We, at least in the Norton office here, we serve as the state liaison for Connecticut, but we certainly try to sync in. Obviously, there are 3 offices that serve Connecticut, and we try to do like basically sort of like a mosaic or like a stitching of the forecast across offices, so that way it's a statewide message as best we can. But yeah, as far as if that will change, I don't have the answer to that, unfortunately, but it is something that we have definitely heard of before.
Hey, Andrew, thanks for and Dave, thanks for the answers there. I did have another question I'm going to send back to one of you, because it's also talking about the radars. It came in pretty early. I think it was when one of you were showing the picture of the radar and the radome, the ball is what they call. So Ashlyn asked, what does it look like inside the ball? So I don't know, either one of you want to take that one?
Yeah, I had showed that picture. Well, it's kind of like a giant satellite dish, really. It's about 27 feet in diameter. So it's think of it if you saw like a big satellite dish or one of those satellite dishes on your house, but significantly much larger. Like I said, about a 27-foot diameter, and it's inside of that dome, and it actually spins, and it spins at different rates depending upon whether you're in severe weather or if you're in what we call clear weather, which is weather that's generally benign, no precipitation. So it's basically a giant satellite dish, it looks like in there, that sends out pulses and then receives them back and determines things like how strong the reflectivity is, whether it's heavy precipitation, light precipitation, but it also determines motion through what we call the Doppler effect, which actually, based on the way the pulse comes back, we can determine whether things within the storm are coming towards or away from us. So a lot of good information on a lot of things we can tell. But yeah, good question there.
Thanks, Dave. Rich, I'm going to send the next one to you. There was a whole bunch of questions while you were speaking about what it's like to fly through a hurricane. In particular, Samantha asked, are you scared personally when you fly through hurricanes?
Okay. Actually, I don't think I would use the word scared. I would say that I'm really, really concentrating hard on my job at that point. I'm very focused. One of the things that I want to emphasize is that we work as a team on board our airplane. We have some of the best pilots literally in the whole world flying with NOAA, and they're very well trained on how to handle the bumps in a hurricane. Essentially, we don't try to fight all of the turbulence in the hurricane. We kind of ride it up and down like a roller coaster, and we try not to put too much stress on our airplanes. So I'm not really scared, but again, I'm very, very focused. I'm concentrating. And part of the reason why is because the data that we send off the airplane has to be correct. And the thing about the internet these days is that within just a couple of minutes of the data coming off our airplane, it goes by satellite to Miami and then is transmitted to the whole rest of the world over the internet. So I'm under a lot of pressure not to make any mistakes, because if I send off some bad data off the plane, everybody in the world is going to see it. So that's really more, I'm a little more nervous about that than I am about the storm. I'm almost too busy to be scared.
Hey, Rich, I have a quick follow-up before I ask my question to one of our folks. But it asks how many people are on the airplane with you when you're flying?
That's a good question.
That was from Marine, I think.
Okay. On the P3 airplane, which is the 4-engine turboprop plane with the propellers, that we can fly as many as 18 or 19 people into the hurricane. We have pilots, we have a navigator, we have a flight engineer up front, we have the meteorologist, which is myself, and then we have a team of engineers and technicians that run the radar system, that actually drop the weather instruments that we're using that fall by parachute, measuring the winds and the pressure and all the other important parameters. And we also have a team of scientists that often fly with us into a hurricane from the Hurricane Research Division of NOAA that's based down in Miami. So you can have 19 people on the P3, and then on the G4, the Gulfstream plane, it's a smaller aircraft, but it can have a crew of up to 9 or 10 people as well. Again, all filling different jobs on board the airplane. Everybody is busy when we're in the hurricane environment.
Thanks, Rich. I was going to pass a couple. We had several questions here about hurricane names. We've seen that common theme from a lot of our webinars. So I saw questions, and I answered a couple of these earlier from Jerry and William, asking about when we first started, and it was about 1950. The first name ever used was Abel, but then we had other questions from Fallon and Edgar that were actually asking about who comes up with the names and, again, how that process works. So I was going to turn that over to Robbie to answer that one.
Yeah, great question. It's a popular question too. And thanks, Andy, for switching over to this slide, which does show you the names that we use in the Atlantic. So the way that it works is that all of the countries in the western part of the Atlantic basin, us, Canada, Mexico, the other countries in Central America, the Caribbean, we all get together and come up with the names, because it's not just us in the United States that gets affected by these storms. So you have to think too that all of these countries may have different languages they speak. We have a lot of Spanish-speaking countries. There are actually some French-speaking countries, some Dutch-speaking countries. So all the names that you see here on the list are actually a mixture of those 4 languages: English, French, Dutch, and Spanish. So they're all voted on. And what we do is we have a 6-year rotating list. So you can see that this year we have our 2020 list beginning with Arthur, all the way to 2025, beginning with Andrea. When we get to 2026, we'll then repeat, go back to the 2020 list and use that whole list all over again. Now, anytime we have a really bad storm that causes a lot of deaths or a lot of damage, the countries will all vote whether or not to retire that name. And that has happened lots of times in the past. And once they retire a name, they will then revote on a new name to replace it. So, for example, you can see last year we had Hurricane Dorian. The countries have not yet voted on Dorian, whether or not to replace it. Most likely that will happen at some point. And then once it is retired, then a new name would be chosen. So that's how it works. It's not just the United States that gets to choose, not just the National Hurricane Center, it's all the countries that are affected by these storms.
Thank you, Robbie. I'm going to send this one to Dave or Andrew, but I'll start with Dave. So this was a question about storms in the Northeast, and it says, why do storms like hurricanes move faster in New England than they do along the Gulf Coast or near Florida?
Okay, well, yeah, primarily on average, yeah, storms up at our latitude here, about 40 degrees north, are typically moving northeast at about 35 miles an hour. The reason they move this fast is often they get caught up by the westerlies, or as we know, like the jet stream. So once they get this far north in latitude, the jet stream usually has the mid latitudes or the westerlies pick these systems up, and generally that's why they have the forward speed that they do.
Yeah,
Thanks,
Dave
Dave.
really hit the nail on the head there with as far as why these things move so quickly when they get up north of 40 degrees latitude, is they caught up with the stronger upper level winds, which you really don't see in the tropics, so they tend to move a little slower down and sort of in the tropical climates. But as you get up here, they tend to be moving along at a pretty good clip. 20 to 30 miles per hour is pretty common.
Yeah, thanks, Andrew. I'll just add that, that makes it a lot more difficult to forecast the timing of when those storms are going to arrive and when they're going to hit when they get up in the Northeast. So it does impact our forecast as we make those further up the coast. So that's why people have to be ready maybe a little sooner than we forecast those winds to occur, in case they do move faster and arrive a little sooner than predicted. I have a couple questions.
That's a great point.
No, go ahead, Andrew.
Yeah, no, that's a great point, Dan. It's these things do move kind of quickly, and you really need to be prepared sort of ahead of time.
Thanks. So, Rich, I have a couple of questions more for you. One from Marcy that I think is a really great question, because I've seen pictures, but it says, is it cool to see the eye of a hurricane in the airplane? And then there's another one from Samantha asking about, when you fly through a hurricane, essentially, how do you get in and out of the storm? I think that, how do you fly right through? What elevation are you at? And then sort of maybe the pattern of going in, how do you get in and out?
Right. We fly what we call a figure 4 pattern through the storm, where we essentially fly straight in towards the center. A lot of people think maybe we spiral in, but we actually don't do that. We fly where the winds are blowing directly off the left side of our airplane. In fact, we use the winds to help us hunt the center of the storm, because even though the winds can be as much as, let's say, 150, 160 miles per hour in the eye wall, what will happen is that as we get into the eye, the winds are going to decrease. And what we do is we're constantly turning the airplane to keep those winds exactly 90 degrees off of the track of the plane that, as we're flying. And what we do then is that will cause the winds to continue to decrease until we get to the exact center of the storm, where the winds are dead calm. which is really amazing, but that's what happens in every hurricane. And then the winds come from the opposite direction once we get past the center of the eye. So that's how we steer into the center. And we usually fly between 5,000 and 10,000 feet above the ocean surface when we're going into the hurricane.
Great, Rich. Thank you for that. The next question I'm going to send to Andy. Andy, this is from Leanne from New York, I believe. And she says, how often do hurricanes like Sandy come through the Northeast?
That's a great question. My wife's name is Leanne as well. So the New York area, so Sandy, if you recall, like that's really the last storm you've had of major impact in that area. We could trace it back to maybe Hurricane Bob was another big one that impacted that area. And so it's not as frequent as we might see, say, down here in the Florida. But the storms that do impact do have a major impact because a lot of times these storms, once they get up in that area, have expanded in size a bit. And so their wind feels a little bit larger. They have these larger surges associated with them. So depending on the time frame we're looking at, it's more like a once every 10 years or so kind of situation. But there's always some sort of threat in that area. I always remember, like over the last several years, almost once every couple of years, there always seems to be some sort of computer model simulation that tries to take a storm towards that area. Luckily, what does happen a lot of times is that the typical westerlies that you have up there will tend to steer the storm off the coast. But there are times, like when we say with Sandy, that the steering flows can change and these high pressure areas can build north of them and turn the storms towards the coast.
Thanks, Andy. I know we're starting to get a little short on time, so hopefully we got time for a couple more questions. I love this question here a lot, and it's made me think the last couple of minutes. So I'll try to send it maybe a couple of you. But it says from Jennifer, it says, my teacher is always having us analyze graphs and data. What is the hardest piece of data or graph that you have analyzed? So I'm going to send that one over to Robbie first to see if he has an answer for us.
Wow, hardest. Well, there's not one piece of data that's hardest, because I think what's hardest for me is that we get so many different types of data. We get the aircraft data from Rich and his crew. We get observations of weather instruments at airports. We get satellite data. And it's our job to take every one of those pieces of information and come up with an answer, if you want to put it that way, for what we think is going to happen. And sometimes all those pieces of information do not agree. So sometimes the plane data we get from Rich might not quite be exactly the same thing with what the satellite's telling us. And so we have to say, well, in this particular case, I believe the plane data more because there's actually an instrument in the storm. Whereas you take the satellite data, that's an instrument way up above the sky, and it's looking down at the Earth. So even though it's giving us great information, it's not actually in the storm measuring something. So in those kinds of cases, we have to weigh the different types of data and come up with an idea of which one we think we believe a little bit more than the other.
Rich, do you have anything to add? I know that you're looking at a lot of data at one time on the aircraft.
Yeah, it's kind of crazy. If you can imagine taking your laptop computer and getting on a roller coaster, and you've got some really difficult math homework to do that you've been assigned from your teacher, and you're doing that homework while you're in the roller coaster, going up and down, trying to hold your laptop. That's sort of what it's like flying inside a hurricane, where we have a lot of data that we have to look at. We have to make sure it's correct. We have to add things to it, and then we have to transmit it off the airplane. The whole time we're riding in this roller coaster, getting bounced around. So it's a real challenge. It's very interesting. Let's put it that way.
Thanks. Dave or Andrew, have anything to add from the local office about analyzing and graphing data?
I would just say that, it's like Robbie kind of said, it's not necessarily any one thing. It's just the wealth of data, and being sometimes just so much data and ciphering through it and coming up with a forecast or the best forecast. That's more than anything. I just say it's just a lot of data to look at. If you're interested in data, this is a job to have.
Yeah, no, and what Robbie and Dave really conveyed, that's sort of I'm right there. it's sort of data overload at times, which sometimes can be a challenge. But no, I think especially as you get more experienced, you get more familiar with looking at weather maps, and that all comes with time and experience. And even so, even if you're certainly if you're in an elementary school, obviously just keep looking at weather maps because you'll get more experience with that. No matter if you're interested in hurricanes, or if you're interested in severe weather, or if you're interested in winter weather, that's for me, that's a big take home for me as well.
Thank you, Andrew. All right, we're running low on time, but I want to get this question in here because it may be a really great way to close. Caleb says he understands hurricane season's coming. What can we do to get ready for it? Robbie, would you like to take that one?
Sure, yeah. So if you go to our website, hurricanes.gov, G-O-V, we have in there, Andy put it back up there. We actually have some hurricane preparedness information for everyone. And there's certain things you should be doing now to get ready for the season. You should be getting some supplies ready. So maybe there's types of food, canned foods, for example, that you want to have in your pantry. It's good to have them now because if a hurricane comes, you're going to start to get stressed and panicked, and your family has a whole lot of things to worry about. And that's probably the last thing you want to have to worry about. If you already have the food there, it's great to have it so you don't have to worry about it at the time. So get the supplies now that you need to be ready. I would also say is find out if you live in an evacuation zone. Everybody along the coast has tools and resources available to them from their states and local towns and cities to figure out if they live in flood zones and hurricane evacuation zones, so that if a storm comes and a local official tells you, hey, if you live in this area, you need to evacuate, then you already know if you live in that area and will do so if you're told to. So those are the two big things. One, start to get your supplies now, and then also have you and your family determine whether or not you live in an evacuation zone.
Thanks, Robbie. I was going to try to squeeze in one more here and maybe ask Andy, and then maybe either Andrew or Dave, and then Rich if they want to add something as well. It's a question about our education. What do we have to study in college to be able to do our job? So I'll start with you, Andy, and then after I close out, I'll maybe let John close us out this morning.
So the National Weather Service, the federal organization, the minimum requirement to be a meteorologist for us is to have a bachelor's degree in meteorology, or it's also known as atmospheric science. There's a lot of other careers out there. There's people on television that don't have bachelor's degree, but some of them do. And so there's quite a diverse group out there of meteorologists. But for us in particular, you need a bachelor's degree, and a lot of us even have master's degrees. And so you have to be strong in science, and you have to be strong in math to get this degree. A lot of coursework in that, but I'll pass that along to other folks to describe what other courses that might be available in it too.
Hey, this is Rich. I really want to emphasize what Andy just said. Right now, you're at the age where you should be taking as much math as you can, and especially when you get into high school, try to take as much math as you can, because that'll prepare you for the kind of math that you have to take in college if you want to be an atmospheric science or a meteorologist. The last thing I'll say is that for all the girls in the class, nobody should ever be telling you that you can't do something because you're a girl, because we have had many missions in the last couple years where all three of our pilots on our G4 Hurricane Hunter jet are women. And we have a couple of women who also fly our P3 Hurricane Hunter planes. So we have plenty of women. We have actually 2 of our flight meteorologists who are women that are hurricane hunters. So it doesn't matter anymore if you're a boy or a girl. You could still do it.
Thanks, Rich. I'm glad you mentioned that because, we've had several female meteorologists on with us for these webinars. We didn't have one today, but folks want to go and look at some of our recordings. They can get to meet folks like Nikki Hathaway that work with you, and a lot of meteorologists that work at many of the local forecast offices. So Really great points, and glad you brought that up. So with that, I think we're going to be out of time today, but I want to thank again our panelists for joining us. I really appreciate everybody being on it, but I'm going to throw it to Robbie to end to tell people where they can find the recording. But again, thanks a lot, everyone, for all those fantastic questions. Hope you enjoyed the webinar this morning.
Yeah, so if you look at your screen, the very bottom link there is to the National Hurricane Center YouTube channel, www.youtube.com/NWSNHC. We're going to put this particular webinar onto that YouTube channel and all the other ones we've done. So we've been doing this for all the different states, from Texas to Florida, all the way up the coast now to New England, and we'll be doing an international version next week as well. All of those webinars are available at that website, so you can watch all the previous ones as well. So I just say that thanks to everyone for joining us. Be safe, be healthy, get ready for hurricane season, and we hope that everybody has a great day. See you later.
Hi, everybody.